Hey guys, welcome back. Here is Samanatif, and I'm going to start the lecture related to separation techniques. Rather, I'm going to continue the lecture related to separation techniques. The previous lecture was related to solid liquid separation. Number one was decanting. It was for the large size solid particles and liquid. And then it was filtration for finer size solid particles and liquid. And there was a third, which was called as centrifugation, followed by filtration. In that, I have separated very, very fine solid particles from liquid. In the fourth one, it was evaporation till dryness. I'm going to write this as well. This was number four, and this is number five now, and that is called as crystallization. Crystallization. Okay. In crystallization, basically we are going to make crystals. Okay, how we are going to make crystals? There is a point which we are going to notice in this, and that is called saturation point or crystallization point. What is that point? How we will achieve that point, and what is the way to identify that either we have reached that point or not? Okay, so for example, this is a glass, and in this glass there is, for example, water, and along with 5 tablespoons of sugar. Okay, before moving ahead, I would like to tell you that this crystallization is for low melting point solid and a high boiling point liquid. For example, I can tell you that this is used for sugar and water. How this is? Sugar will be caramelized if you are going to heat it directly. Sugar and water directly going to be placed on flame. What will happen? Water will be evaporated, whereas sugar, the mixture of sugar and water will become thicker, and finally sugar will turning itself into a caramel type of thing. That brown color thingy will be formed. Hence we will not be able to take those crystals of sugar back. Okay, so how to take sugar in the form of crystals, the white crystals of sugar, along with the complete quantity of sugar which we have added, and how we can separate it completely from water. Okay, so here we have taken 5 tablespoons of sugar along with 1 glass of water, and now we are going to add 5 more tablespoons of sugar. What we will observe in this case, that is, there will be water, and this is sugar over there. For example, I'm going to draw sugar with the blue color. Okay, or with the pink color is nice. Okay, so for example, we are watching that lots of amount, for example, to out of total 10 tablespoon, lots of amount, let's suppose that 9 tablespoons of sugar are dissolved. Rather, 9 tablespoons of sugar are becoming part of that water, whereas only 1 tablespoon of sugar is left at the bottom. It is not going to dissolve, and we can say that we are continuously stirring, but this 1 tablespoon is not getting dissolved. Okay, now what we are going to do is this, that we are going to heat it on a burner. All right, so we are going to heat it here, and this is the sugar solution. And we have seen that not only that remaining 1 tablespoon of sugar is dissolved completely, rather we have added 5 more tablespoons of sugar in it, and we are observing that they are going to be dissolved in that water which is on flame now. Okay, so it is even getting dissolved in that. Okay, so what we are observing now, that now few crystals, or you may say a small amount of sugar is remain at the end. Okay, so 5 tablespoon at the start. To separate those 5 tablespoons, we have added 5 more tablespoons of sugar, and now we have seen that before burner, more amount, much amount, or you may say most of the 10 tablespoon is dissolved. Now remaining 1 tablespoon is left at the bottom. We have heated it, added more 5 tablespoons of sugar. The remaining 1 tablespoon of sugar along with 5 tablespoons of sugar are dissolved. Only a small amount is not getting dissolved on the burner even. Okay, so now what we have in with ourselves, with we have, for example, a glass rod. Okay, this is a rod which is made up of glass, let's suppose. Okay, now we are going to immerse that glass rod in that solution, in that hot solution on the burner, and we will take that rod out of the solution. Okay, so we will check it after cooling that either the crystals are developing on that glass rod or not. If crystals will be developing on that glass rod, that is called as the crystallization point or the saturation point. So what is the crystallization point or saturation point? When no more amount of solute is getting dissolved in solvent, when no more amount of solute is becoming part of that solvent to make the solution. So there are few terms which I have just used, and what are those terms? What this is a solution, the term number one, and the solution is made up of two partners. One of them is solute and the other is solvent. Okay, so what is a solute? It is the one which is in the smaller amount, for example sugar here. And what is a solvent? It is the larger amount one, and here it is the content, which is water, is considered as a solvent. Okay, so they are both dissolving into each other, mixing up into each other. We cannot segregate the two. That is called as a solution. Okay, there that solution is something which is separated from the mixture. Okay, so make it very clear. One form of the solution is that one form of the mixture is solution, whereas the other is they are immiscible into each other. Okay, so for example, the two are there. For example, we can say our tea leaves, for example, tea grains you may consider, and water. The tea grains are not dissolving themselves, they are giving a color to water, but they are not getting dissolved in water. So that is no doubt a mixture, but that is not a solution. So what is a solution? A homogenized solution is that in which the solute, the smaller amount, is becoming part of that solvent. We cannot segregate between the two. Okay, so now what we are going to do, so initially I'm going to repeat the whole thing. Initially, we have taken a glass of water in which 5 tablespoons of sugar are there. We want to separate those 5 tablespoons of sugar from water. And what we have done, we have added 5 more tablespoons of sugar into it. Okay, and then what we have observed that out of total 10, 9 are becoming part of the solution, whereas only 1 tablespoon is left at the end. Now what we are going to do, we are going to heat it on the burner. Then we have added 5 more tablespoons of sugar into it. All those 15 tablespoons of sugar are becoming part of water. Only smaller amount is not getting dissolved on the burner even. Now we have taken a glass rod. I'm going to write down the name here as well. This is called glass rod. It is basically a rod which is used for stirring purposes, and that is made up of glass. Now we are going to immerse that glass rod into the solution, and taking it out, making it cool. And what will happen, we are going to observe if crystals are forming on that glass rod. It is just giving us an idea that we have reached the crystallization point or the saturation point. Saturation point or the crystallization point is that on which no more further amount of solute is becoming part of that solvent, is not going to dissolve anymore, rather it is going to be settled at the bottom. After this stage, we are going to turn off the burner, and we are letting this mixture, letting this solution with smaller amount undissolved at the bottom, and we are letting it cool at the one side of the lab. What will happen, the whole mixture will be cooled down. As a result, all the 15 tablespoons of sugar will be settled at the bottom. Water will be at the top. Now, if we are going to taste that water, by the way, we are not allowed to taste anything in the lab, make it very, very clear. But for example, let's just we are performing this experiment in our kitchen, for example, okay, and we are going to taste this water. This water will be sugarless. It will not have any sugar content because all the sugar content is settled at the bottom. Might be many of you have enjoyed a thing called rock candy. So rock candy is formed through this crystallization process. Basically, the threads are arranged at the bottom of this mixture so that the whole sugar crystals, which are sticking with each other, holding each other tightly, can be taken off, can be taken out of this mixture, can be taken out of this container easily with the help of those threads. So this process is called crystallization. All right. Now I'm going to take you to the next topic, and that is a very important topic, and it is related to solvent extraction. Guys, the word solvent extraction itself is enough to explain its meaning. And what is that term telling you? That, for example, we have two solvents and the two solvents are immiscible into each other. What is the meaning of immiscible? It means that they are not going to dissolve into each other. For example, oil and water. We already know this thing that oil and water are not dissolve into each other. How we can separate the two? With the help of solvent extraction. There is another mixture which is called carbon tetrachloride along with water. We cannot separate carbon tetrachloride from water if we are not going to perform this process which we are going to study now. Okay, so this is called as solvent extraction, and here is the apparatus which we are going to use for this, and this apparatus is called as the extraction funnel. Okay, so I am going to draw this, brother, I'm drawing this extraction funnel. Guys, this is called as cork. Cork can be made up of rubber, can be made up of glass, or it can be a wooden cork as well. So this is called as extraction funnel. Okay, extraction mean to take it out, to take one liquid out of the other liquid. Okay, extraction funnel. Okay, guys, this method is based upon the difference of the density of the two liquids. One liquid will be of higher density, whereas the other liquid will be of lower density. For example here we have taken the whole mixture of oil and water, and we can observe this thing that oil being lower in density will make the upper layer, whereas water being higher in density will make the lower layer. Okay, so oil is lighter, so that's why it will make upper layer. Oil and water combination can be observed in our homes as well. Many times we are observing this thing that on some foods oil is making the upper layer, oil is making the top layer. Okay, because oil is lesser in the density, whereas water is heavier in the density. So that's why water is making the lower layer. Okay, now what we will do, we will mix this mixture, we will shake this mixture properly, and then we will let it stand so that both of the layers can make a proper thing, both of the liquids can make proper layers, can be separated, segregated properly. Okay, now we are going to open this tap. Okay, I'm pointing it out right now. We can open this tap. What will happen? Only water will start coming out. Only water will start coming out. But this method has some drawbacks as well. What are the drawbacks in this method? That there is a possibility that few drops of oil can come along with water, or few drops of water can be remain with oil. So this method is not giving us 100% separation. All right, this method is not giving us 100% separation. Okay, if we are talking about the method number two, that is called as carbon tetrachloride and water, it is not method number two, sorry, it is the example number two. So if it is carbon tetrachloride, I'm writing the name for this as well: carbon tetrachloride along with water. Okay, so for example, if we have taken carbon tetrachloride and water, carbon tetrachloride is lighter, is lower in density, will make the upper layer, whereas water being heavier in density will make the lower layer, just like oil and water. So we can the problem which I have just told you, that there cannot be 100% separation, can be rectified, can be handled by adding a dye, for example, a pigment. Okay, but we have to select such type of a pigment in which we should have an assurance that this pigment is soluble in one of the liquid. For example, the pigment is soluble either in water or in oil. The pigment should be soluble either in carbon tetrachloride or in water. In this way, the separation can be improved, the separation quality can be improved. We can look into the two liquids more clearly. It can give us more appropriate approach to the separation. Okay, so what is solvent extraction? It is to extract one solvent from the mixture, and in this case, for example, we have oil and water. We can keep the whole mixture, we can put the whole mixture in extraction funnel with the help of a filter funnel. Guys, this was the filter funnel. I'm going to draw this filter funnel again, and I have shown you this filter funnel in the video which was related to the lab apparatus. Okay, because this extraction funnel has a narrow top at narrow top at the surface. You can see where cock we have mentioned. So through that, it is a little bit difficult to add the whole mixture more appropriately. So we are going to use this filter funnel, and then we can shake the whole mixture. We can place it in the stand with the clamp, and then after the management of the two layers, after the arrangement of the two layers, we can perform the experiment. Is that clear now? Okay, guys, if there will be any question, you people are more than welcome to mention it in the comment box. I will definitely try to answer as many as possible. All right. So, guys, there is another question related to solvent extraction that can be applied to any other mixture. Guys, remember this thing, it is only implementable on those two liquids which are immiscible into each other. We cannot implement it to any gas or any solid. It is only for liquids, and also those liquids which are immiscible into each other. We cannot separate water and alcohol through this method. Why? Because water and alcohol are soluble into each other in all composition, in all percentages. Either one is 90% or the other is 10%, or one is 80% or the other is 20%. They are 100% soluble into each other. So such type of mixtures cannot be separated through solvent extraction. Okay, right now I am changing the page and I'm going to the next method, and that is called as simple distillation. Simple distillation. Make sure that the diagrams related to simple distillation and the other topic, which is fractional distillation, should be fitted in your mind very, very clearly, because sometimes examiner is drawing the half of the diagram and he is expecting from you to draw the half of the diagram. Sometimes he is mentioning something wrong in the diagram. Sometimes he is asking about the labeling. So make it very, very clear that these diagrams of simple distillation and fractional distillation should be in your mind. Okay. I am trying to show you the diagram of simple distillation. Let me show it to you. I have that diagram of simple distillation with me. Okay, so this is the diagram of simple distillation. You guys can see this thing, that what is simple distillation. I'm going to read all these things. So for example, this is the mixture, and this is the mixture flask in which this mixture is there. This mixture flask is placed on a tripod stand. Before moving ahead, I would like to tell you that this simple distillation is used to separate the mixture of sodium chloride and water. I'm writing this right now. This is used to separate the mixture of sodium chloride and water. Okay. Guys, let me tell you very clearly, sodium chloride has a melting point of 801 degrees Celsius, whereas water has a boiling point of 100 degrees Celsius. Okay. Sometimes students are asking that we can separate this mixture with the help of evaporation till dryness, in which we are taking the whole mixture, keeping it on the burner, water will be evaporated, sodium chloride will be left. Yes, we can separate this mixture through evaporation till dryness, but in that case, basically we are losing the whole content of water. So if we want to save the total amount of water, and if we want to save the total amount of salt as well, we have to implement this method called simple distillation. So where we are using simple distillation for those solids which have very high melting point and the liquids having low boiling point. Okay, I have given you one example. Before moving ahead, I would like to inform you that there is one industrial application for simple distillation, and that is called as desalination. Desalination. So what is desalination? It is a method which is used to remove the salt from seawater to change it into drinking water. Okay, we know this thing that we cannot drink seawater. Why it is so? Because Seawater has lots of dissolved salts in it, so we have to remove those dissolved salts from that to change it into, to shift it into drinking water. Okay, so what we have done, we have taken this mixture flask. In this mixture flask we have the mixture of sodium chloride and water. Okay, and there are some anti bumping granules as well. So what are these anti bumping granules or anti bumping granules? So basically I will tell you the reason for adding this as well, but there is a burner here. Let me explain you the diagram first, and then I will tell you the reason for each and everything. Here is a burner. This burner can be electric burner. This burner can be Bunsen burner if you are performing it in the lab, for example. And it is a tripod stand. Obviously, the third leg of the tripod stand cannot be made on the paper. All right. So there is a mixture flask here. At the top of the mixture flask, there is a thermometer, and you can see this thing that there is a stopper. The stopper is also called as bung. The stopper is also called as bung. For example, I'm writing here, this is called stopper, or it is called as bung as well. Okay, so now remember this thing, that opposite to the bulb of thermometer, there is an opening towards the condenser. Okay, so this is called condenser. Now the reason is this, that what is condenser? We already know this thing, that condenser is an apparatus which is used to shift the vapors of a substance back into the liquid state. Okay. Now, this condenser has a water jacket. So, what is a water jacket? Water jacket is an apparatus around the condenser. It is a tube around the condenser in which water is flowing. The water which is flowing in this water jacket is in the anti-gravitational direction. Why in the anti-gravitational direction? So that coldness of water can be shifted to the condenser for a longer interval of time. I am marking here, this is the cold water. This is flowing in this water jacket in the anti-gravitational direction. You can see this thing, it is going from the bottom. Guys, examiner is sometimes drawing these arrows in a wrong direction. He is making this down and making this up, okay, making this down and making this up, or sometimes opposite like that. Okay, for example, this is up, he will make this down. If this is up, he will make this down as well. Okay, so he will make it in the gravitational direction, and then he will ask you what is the mistake. So you should say it very clearly, that arrows of the water movement should be opposite. Okay, water should be moved, water should go in the anti-gravitational direction. Why it is so? Because if water will fall in the gravitational direction, water will be in contact with the condenser for a shorter interval of time. Water will fall down quickly. But if it is moving in the anti-gravitational direction, what will happen? It will be with the wall of the condenser. It will be remain with the wall of condenser for the longer interval of time. Okay. So this is the reason. That's why we are flowing, we are sending water in the anti-gravitational direction. Okay. Now what is happening? We can see this thing, that here is the condenser, and after that condenser we have what? We have this receiver flask, and this receiver flask is open. There is no bung or a stopper with this. Okay, now, point number one is this, that you should know this thing, that why anti-bumping granules are there. First of all, what are anti-bumping granules? This can be marble chips, this can be glass beads as well, or the marble chips. Okay, why they are there? So that the solid may not start bumping, may not start sticking to the walls of the container while boiling with water, and while boiling with the liquid. So, and you may say for smooth boiling. Okay, for smooth boiling we have taken the anti-bumping granule, so that bumping may not occur, very clearly. Okay, and then examiner will not draw the stoppers over there or the bung over there, and then he will ask you What is the mistake? If the bung or the stopper will not be there, this thermometer will fall down in this mixture, okay? And then he will make this opening at the wrong place, might be here, might be here, okay? Remember this thing, that this opening should be opposite to the bulb of the thermometer, okay? Otherwise you will not see the exact results. So this will tell you, for example, thermometer will tell you the temperature of 100 degrees Celsius. It means that all the water is start moving from here and shifting on this direction. If temperature on thermometer will be more than 100, for example 101 degrees Celsius, so it is giving us an assurance that all the water content is removed. All right, so remember this thing very very clearly, that in this case water is removed 100%. Okay, so now the point is this, that after this case it can give us an assurance that water is removed. Now I'm moving towards the receiver flask, for example, that there must not be a bung or a stopper in the receiver flask. Why it is so? Because if there will be a receiver flask closed tightly, the liquid which is coming from the condenser is comparatively at a higher temperature, as compared to the normal temperature of the liquids, as compared to the normal temperature of the liquid from the room temperature. Okay, so that high temperature of the liquid can create a pressure. Due to that pressure, this flask can burst out. So there must not be a bung or a stopper in the receiver flask. So I have told you the reason of the anti-bumping granules. I have told you why there should be a stopper. I have told you where should be the position of the bulb, why there is an anti-gravitational direction, anti-gravitational flow of cold water, why there is a cold water to increase the efficiency of the condenser, what is water jacket in which cold water is flowing, why there is no bung or a stopper. When student will get to know that all water is removed when the temperature on the thermometer will be greater than 100 degrees Celsius, it is just giving us an evidence that all water is removed. All right, so the only thing which is left is sodium chloride now. Okay, so this is how desalination is used. Desalination is a process through which the salt is removed from the seawater, and desalination is an industrial application of simple distillation. All right. Thank you very much, guys. We are left with the topic of fractional distillation for this separation techniques, and inshallah, I'm going to upload that as soon as possible. May you all rise and shine in chemistry due to this channel, inshallah. Thank you very much. Take care of yourself. Allah Hafiz.